Willkommen, bienvenue, welcome. This talk is about searching in a distributed world with Spring Data Redis. My name is Julien Riou. I'm a solution architect at Redis Labs, and we'll be talking about Redis and Spring. So the agenda for today, first we'll talk about what is Redis. We'll look at searching with Redis. And then we'll talk about Redis and Spring, how they integrate. And we'll have a demo that you can take from the GitHub repo after this talk. And finally, we'll talk about Redis Enterprise, which is software that Redis Labs provides. So yesterday, we announced that over 1 billion containers have been launched using our Docker image. So I'm very proud of this achievement. What is Redis? Redis is the leading in-memory database. It has 3 unique characteristics. One is performance. The other is simplicity, with a wide array of data structures that you can use. And the third key characteristic of Redis is extensibility with Redis modules. Who in the room here is using or has used Redis? Okay, pretty much the majority. You probably know already about performance. The Redis is famous for extremely high throughput, very low latency. You can see here is in this benchmark performed by a third-party company. So not just raw performance, but also efficiency. If you look at how many machines are needed to perform 1 million operations per second, in this case just writes, you'll see that it's an order of multiple orders of magnitude less than competing products. So again, this is due to the fact that Redis is in memory, but also very efficient data structures, which are can take multiple shapes. So Redis at the base is a key value store, but the value can take different shapes. So the most commonly used one is strings. Strings are binary safe. You can store byte arrays in there, so you're not limited to just text. On top of these strings, you can also do bitmaps and manipulate bits inside that byte array independently of each other. Bit fields are a way to store integers in a compact fashion within a string data structure. And then you have more complex data structures as part of Redis. So hash is very commonly used to store documents in Redis. So hash, under a single key, you can have multiple key value pairs that you can access individually. Lists is a way to implement a queue semantic inside Redis. So you have an ordered set of elements. Sets, also a collection of elements. In this data structure, there's unicity for the members. You can add the same member multiple times. It's not going to show up multiple times in the collection. So similar to a set in Java. Sorted sets builds on top of set to provide scoring on the elements. So you can retrieve elements by numeric score. Geospatial is a data structure that lets you do geo commands. So like give me the data that's within a certain radius around that GPS coordinate. Hyperlog is a probabilistic data structure that allows you to count things with a margin of error in a very compact fashion. And finally, the latest addition to the Redis data structures is streams. Streams are similar to what you would do in Kafka. You have the notion of messages with a timestamp, and you can query these messages, first store them in Redis and query them. So you have the notion of topics and consumer groups like you have in Kafka. The main difference here is that this is memory-based. So at the bottom here, you can see an example of what you can do with one of these data structures. In this case, it's a sorted set. So if you want to retrieve the email address of a user with the highest bid in an auction that started at a specific time, you can access it using the zrevrange command, which basically gives you reverse order elements of a sorted set. So you can see how compact Redis commands can be if you really leverage the power of the underlying data structures. The third characteristic of Redis that I wanted to highlight is extensibility. So there's a Redis modules API that you can use to implement your own data structures and commands. So this has been used by Redis Labs to offer a few modules that cater to different needs. One of them is Redis Graph. This one is based on the Graph Blast technology, using sparse matrices to compute entity relationships. JSON, ReJSON is a module that implements native JSON documents. So you can retrieve documents as a whole or just specific fields inside a JSON document. Again, everything in memory. Redis ML is a machine learning module that lets you do logistic regressions, polynomial regressions, and other models where you can fit and apply the models in memory. And finally, the one that's probably the most popular, it's RediSearch. It's a full-text search engine that's very high performance. So we'll just talk about RediSearch in more detail right now. RediSearch, so again, uses the Redis modules API. It provides simple and fast indexing and searching. So it's not just about searching, it's also how fast can the indexing be. Typically, when you look at Elasticsearch or other Lucene-based search engines, you will see a lag between the time you index a document and the time it's available for searching. In this case, it's all real time. So we have in-memory data structures that are very efficient, and we offer a flexible query language on top of that that's, of course, provides full-text searching with stemming. Stemming meaning you can derive multiple words from a single root word. Typically in English, when you have a verb like to eat, you want also to match with eaten, I ate. So all these are derived from the stemming mechanism. Phonetic matching is a way to do some kind of how does a word sound. RediSearch understands that and can let you match all the documents that have these words that sound the same as the one that you're providing. And finally, there's numeric and geo filters that you can apply in your queries. So very expressive language with high performance. You can see on the right some benchmark that was done comparing RediSearch with Elasticsearch and Solr. So you can see very good performance compared to other search engines out there. In terms of commands that are exposed by the RediSearch module, there are mainly three. So two of them, search and aggregate, reuse the query language as I just mentioned to provide different features. So searching will return you documents that match your query, and the aggregate command will let you do MapReduce style transformations on top of these documents. So you can do statistics like count, sum, min, max, average, all sorts of interesting distributed algorithms on top of your data. A third feature or a third command in the RediSearch module is Autocomplete, and we'll look at that in more detail in just a second. So if we look at a query example, if you have documents that contain information about cars in Redis, you can use simple keyword matching. In this example, if you type Ford, this query will return you all the documents that contain the word Ford. You can make it a little bit more complex, and you want to match on all documents that have either Ford or have a word that starts with CHEV for Chevrolet. So this is prefix filters. You can also do negation of the term. So if you do -explorer, documents that contain the word explorer will not be returned as a search result. And you can also do optional. This one will not make it a strict requirement for the documents to be returned, but the ones that contain the word truck will be returned before the documents that don't contain the word truck. We can do numeric filters. So in this example, you want to give me documents that have the field year between 2001 and 2011. And you can also do geolocation. So if you want to get the cars that are around a 10-mile radius from that location, which is right here, then RediSearch will go and do that calculation for you.
Is that search based on key or random?
It's documents. And actually, we'll show an example of how this works in just a second. Autocomplete is an interesting feature that gives you, it uses radix tree-based data structures and it's optimized for real-time as-you-type completions. So if you provide a word, and you provide just the beginning of a word or a phrase, as you can see in the example here, it starts at the top of the tree and goes down the tree as you type. So if you type the character R, it's going to complete you with either OM or UB, and then as you go down, you refine your completion. It's a simple API. You can add a suggestion with a command, get a suggestion with another command, and then finally you can delete suggestions with a third command. So you only need to know 3 commands to make this work. And again, this is all based on memory, so extremely fast, so very well suited for websites where you have to provide some help for your users. Now let's talk about Redis and Spring. There is a module or a component of Spring called Spring Data Redis that provides a lot of the abstractions and integrations with Redis. So at the base, it's a connection package on top of 2 very popular Java drivers, Redis and Redis. Redis being the reactive driver for Spring. So if you use Spring Data Redis reactive as a dependency, it's actually using Redis behind the scenes. So very different philosophies between Redis and Redis. Redis is very one-to-one mapping, imperative style integration with Redis. Redis is more using the reactive philosophy where you have a single connection that manages a lot of requests at the same time. Spring Data Redis provides a Redis template that gives you a grouping and an interaction with Redis that's more suited to Java developers. You will see an API that's really familiar to Spring and Java users. It also provides abstraction for PubSub. So I didn't mention that before, but Redis supports PubSub messaging. So it's exposed in Spring Data Redis. You can do repositories. It's a very popular feature in Spring Data Redis. We can map objects to any of the Redis data structures. Most commonly, the hash data structure can map really well to your object graphs. So Spring Data Redis does that for you automatically. If you have an object graph you want to store in Redis, it's going to do the mapping and the conversions that are necessary to make this happen. And finally, there's an out-of-the-box Spring Cache implementation where you can, if you have expensive methods that take a very long time to compute, for example, if you access databases or mainframes or systems that don't typically, are not typically built for real-time queries, you can use the Spring Cache implementation to use Redis as a cache that will be done transparently. So you just tag your methods with the @cacheable annotation, and Spring Data Redis does the rest. Every time you call a method, it's going to store the results into Redis, and the next time you call that method, it's going to retrieve the results. Of course, you can specify expiration, all the rest. Let's look at the demo application that we'll run in just a second. So I built a demo around data from discogs.com. So discogs is a website and also a music database that's crowdsourced. So you can access the database dump from discogs.com. If you go to data.discogs.com, you'll see available for download a bunch of XML dumps. So it has everything around albums, artists, labels, and the one that we're going to play with is the releases. So basically albums from the beginning of times. Basically a bunch of audio recordings and their metadata. So we know what's the artist behind the album, what's the title of the album, what year was it released, what genre it is, what style of music. So all this information we can use to build this demo. So it's going to be using Spring Batch to read every record in this big XML file. And for each record, it's going to use Spring Data Redis to insert that document into Redis using the repository feature. So the XML record is essentially an object read by Spring Batch. That object is going to be converted to a Redis hash data structure, and the 1.3 million records that come from the Discogs database are going to be stored as Redis hashes. In addition to that, just storing the raw documents, we'll have an index in RediSearch using the Java library called JRediSearch. So it will create the index, and for each document, add it to the index. Now for the front end, we have an Angular application that's going to tap into the power of Redis and RediSearch. So for this, we'll have the Spring Web controllers receiving requests for the documents themselves with a hash get. And then we'll have, again, RediSearch Java client letting you perform searches on top of these documents. So we'll be able to retrieve albums by keywords contained in these documents or by year, etc. And another feature of this demo will have the Discogs API. So Discogs API provides you with even more information based on an album ID. So you can enrich that data coming from the database dump. And for example, for this demo, we'll use the images that are basically the cover images of an album. So every time there's a request, we will go to Discogs API, get the image for the album, display it in the Angular application. But that's very costly. It takes a lot of time, and you are throttled when you use the Discogs API. You can only do 60 requests per second. So what we will do is use Spring Cache to store these images as byte arrays inside Redis and retrieve them every time we've already seen this album. So let's get started. I'll show you the data first. So I have a Spring Boot instance running here in my terminal. Let me see if I can make this bigger a little bit, even though that's not the main point of the demo here. And I have the Redis CLI. Redis CLI is packaged with Redis, and you can interact with the Redis server and see what's in there. So for example, if I type info, this is one of the commands. In the back, can you see the screen, or is it too small? It's good? OK. So if I type info, this is a command in Redis. They can see how many entries are in the database, what kind of metrics we have around a database. And you can see at the bottom we have, this is actually extremely small here. You can see we have 2.3 million records in our Redis database. And if we do, let's say, a search, we can use the full text search command. So if I do, give me all albums that contain the word Spring. Right, so this returns me a list of documents, document IDs that contain that word. So if we take, for example, the last one returned, and I can't see my, OK, here. OK. So I'll use the hgetAll command. This one gets you the whole hash responding to a document. So I'm using this convention, which is very used world, where you have the prefix of a key and then the ID of the document you're trying to get. So you can see here, it's an album by the band called the Hot Springs, and the title, it's All Right. So it matched our query here. I can do a bit more complex, give me everything that starts with Spring. So if, again, I go and get that document, you'll see that it matched something a bit more complex with the Spring Still band. Never heard of them, but it's band from 2008, or that release was 2008. You can see what Spring Data Redis did for us with the underscore class parameter. So this is used by Spring Data Redis to deserialize an object when it comes from Redis. So this is what's going to be used when we run our searches and try to get the documents. So now let's look at the web application that's implemented in Spring Boot and Angular. So it's packaged as a single jar using the WebJar method. So everything is running a single Tomcat server. So here we have, I'll zoom in a little bit. There you go. So we have two fields in this application on the website. We have an artist field, and we have a query field. The artist is an autocomplete field. So every time I type something, it's going to give me entries in my suggestion index that match that. So if I type Dusty, you'll see a list of artists that match that beginning. So it can do Dusty Springfield. And no criteria so far. I just want to get all the albums by this artist. I click Submit. And you'll see it takes some time for the images to come back. And that's because it's going after the Discogs API one by one, trying to get the images. Now, if I run the same query again, the images will be in the Redis cache. So if I click Submit, it should be faster. So here you go. The images are stored in Redis. If I look at the entries that Spring Cache automatically created for me, I'll just do keys, image, everything that starts with image. And you'll see there's 20 images that were returned that were fetched from this Cogs API and stored in Redis automatically for me. I didn't write any code for this. This is all Spring Cache doing it. And you want to see the content of this. So if I do images 319832, you'll see that it's probably mistyped something here. The images, oh, I missed a colon. So it's a string. As I told you before, the string can store binary data. So if I actually look at the content behind this, and I do images 319832, you'll see it's all binary data stored inside Redis memory. So, of course, there's many more entries in there. If I do Bruce Springsteen, you'll see there's multiple entries for the word Bruce Springsteen too, so that shows you the auto-completion. And I can do more refined searches. So if I run a first time, I get everything from Bruce Springsteen. But if I want to do, give me everything that Bruce Springsteen released between 1980 and 1990. So that shows you the numeric filter on top of the year field. So now we have only documents that are from 1980 to 1990. You can see it's mostly early 90s, early 80s. But by default, my searches are only returning 20 documents, so it probably produced much more than that. And I can do a refined search. Maybe I want to get only pop music that Bruce Springsteen released between 1980 and 1990. So again, I refine my search. It returned extremely fast, but this Cogs API is slowing me down. So if I do the same query again, it's returning instantly. So everything in memory at this point. OK. So let's resume our presentation. If you have questions after this, or if you want to look at the code, we can do after the talk. All right. So what did we see in this presentation? So we saw how to quickly write and deploy stateful Spring applications with Redis and RediSearch integrated with Spring Data Redis. The data ingest was done using Spring Batch, and then we used caching and other features from Spring. But there's a lot you can do in addition to this that's provided by Spring Data Redis and the Spring framework. So if you look at the session store, for example, Spring provides that out of the box for Redis. So you can have a distributed session store for your Tomcat servers or other Java-based web servers. So now let's talk a bit about the Redis Enterprise. So again, Redis Enterprise is software that Redis Labs provides on top of Redis. It embeds Redis, and Redis Labs is the home of Redis open source and provider of Redis Enterprise. So Redis Enterprise provides enterprise-grade features on top of Redis, things like performance at scale, linear scaling of your databases by adding more hardware as your needs grow. Provides robust security for data in motion, data at rest, HA, durability, active-active geo-distribution, which we'll look at in a second. Still a multi-model database, very well suited for microservices where you have different needs, but you don't have to spin up a new infrastructure every time you have a need for a different database. You can do all these on the same Redis Enterprise cluster. It has built-in search with enterprise features and provides tiered memory access. That's a very interesting feature that lets you extend RAM onto flash, onto SSDs. So very useful if you have a lot of data in Redis, but you want to save on infrastructure costs. This gets you there with performance degradation that's usually not noticeable as long as you have access patterns in your data where there are hotspots. And finally, automation and support provide a wide variety of deployment options in the cloud, on-prem, in PCF, and we'll look at that in just a sec. Active-active geo-distribution, very interesting technology based on CRDTs. This is academic research on how to do strong eventual consistency. So it's based on the notion of rules around certain data types. You know that in Redis, it's a data structure server. There are different rules when you want to resolve conflicts that might happen in different parts of the world when you write to the same keys at the same time. This is why you have multiple Redis Enterprise clusters that can be actively responding to write operations, and the synchronization and the conflict resolution happens happens with this technology. So for example, if you are trying to insert data in a set at the same time in different parts of the world, there are rules in place to ensure there's no loss of data and no overwrite of your data. Redis Enterprise runs on PCF. We have a tile for PCF. So when you install this tile, it provisions a Redis Enterprise cluster on which you can create any number of databases. And again, integrates with the rest of the stack with Spring. So if you just do a bind between your microservices or applications and Redis instances, you don't have to do anything but specify the service name, and automatically your applications will be connected to Redis databases. So all this, of course, works with dynamic route services and API management on top of it. So very full features integration with PCF. If you want to dig a little deeper into what we saw today, here are a few links. You can get the code behind the demo. If you go to GitHub and to that Redis repository, you'll get the code and can dive into each of the components of the demo. Also a link about RediSearch. If you want to know about all the functionality, I couldn't go very deep into all the features of RediSearch, but everything is documented there. And finally, Redis Enterprise. If you're interested in how to bring this in your environment, look at this link. You can reach us on Twitter at Redis Labs and follow the Redis hashtag on Twitter as well. Thank you very much. I'll be available for questions after this.